Hello everyone. So today we are going to study this chapter of your science, which is one of the chapter of your physics, which is light, reflection, and refraction. Okay. So before starting this chapter, few things which you need to know. So guys, we see a lot of object around us. Correct? What is light? Actually, you will have to understand this bit of this a single word which is light. So guys, we see a lot of object around us, correct, during day or in the presence of light, but in dark room we are unable to see anything, correct. So the question here is, what makes things visible during the day or in a light? Correct. Why we are not able to see any object in the dark? So this is the question. So answer for this question is that any object, whatever we see in the daylight or in the day or in normal light or like in the tube light or in the normal bulb, so every object reflects light that falls on it. Okay, and that reflected light when received by our eyes enables us to see the things. Correct. So there are number of common wonderful phenomena which are observed in our daily life which are associated with light. Okay, so what are those? Like you can see your image in the mirror, correct? You can see your image in the mirror. So can you see your image when there is a in the dark room? No, you can only see your image in the mirror when there is a light. Okay, either in the daylight or in the like light of any bulb or tube light. But will you be able to see your image in a dark midnight? No. Okay, so that's again one of the wonderful phenomena of light. Twinkling of stars. Okay, you have seen the twinkling of stars, beautiful colors of rainbow. So these are the things which we like generally see in our daily life. Okay, which we see in our daily life, correct. So now we will start. So after this, one thing come is your ray of light. So what is your ray of light? Okay, so see beta, ray means just one, everyone know what is ray, correct. So a ray of light, how we are going to define a ray of light? So we can say that ki by observing the common optical phenomena around us, whatever I have just told you, we may conclude that light seems to be travel in a straight line. How we can conclude that the light seems to be travel in a straight line? For example, like all the opaque objects. What are the opaque objects? Those who are not transparent, they are opaque. Okay, so there are three things: transparent, translucent, and opaque. So transparent means you will be able to see the things clearly on the other side. Translucent means even though you will be able to see the things on the other side, but those things are not very clear. Okay, and the last one is opaque, means you will not be able to see anything on the other side of the object. So those kind of objects are opaque, like your human body. Okay, that's an opaque object. Okay, so all the opaque objects like our body, they cast shadow, correct. So because of the straight line behavior of the light, of course, if there will be the straight, if the light will not go in the straight line, and suppose they will go something like zigzag zigzag zigzag, and a person is standing over here, okay, so there will be no shadow of him, correct. So the shadow of that person defines that the light goes in the straight line. So the fact that the small source of light casts a sharp shadow of an opaque object points to the straight line path and the path of the light, and that source of light in a straight line is called a ray of light. So you can say that a source of light in a straight line, a source of light in a straight line, okay, because of which there is a sharp shadow of any opaque object, so that source of light is called your ray of light. Hope you understand this. Okay, so now as I am telling you that light goes in a straight line, light goes in a straight line, but there is a contradiction. What is that contradiction? So contrary to my statement that the light always travel in the straight line, there are cases of diffraction of light. What is beta? Diffraction. What is diffraction? I'm not going to tell you right now, but there are cases of diffraction of light, and this you are going to study in your senior classes, probably in class 12th. Okay, what is diffraction of light? Okay, so in this case, in case of diffraction of light, where light is like that light, it's is in the form of wave. Instead of traveling in a straight line, light is thought of as a wave. That light actually travels like this. Okay, that we call wave optics, also what we call wave optics. So there are actually the study of light is called optics in physics. Okay, the study of light in physics is called optics. So it's further classified into ray optics and wave optics. So in the ray optics means where the light travels in the straight line, the wave optics where we consider that the light travels in a wave form. So this wave optics you are going to study in the higher classes. In this class, in this chapter, we are going to study the ray of light and its mainly reflection and refraction behavior. What are those behavior, beta? Reflection and refraction. Reflection and refraction. So these are the things which we are going to study in this chapter. So hope you guys are clear ki what we are going to study, what is light, what is ray of light. Okay. So here, so this is your chapter name, light, reflection and refraction. So even though in a ray optics there are a lot of stuff, so we are not going to study everything. We are mainly focusing on reflection and refraction. Hope you guys understand this. If anyone is having any doubt, guys, please don't hesitate to ask me question. You can send your questions in the comment section, or you can drop me an email also, where info @rapidgyan.com, info@rapidgyan.com. So if you are going to send the mail, I will definitely respond to your emails, your query. And if your query is something which cannot be written in the email, so I will make a video and I will send it to you guys. Okay. All right. So let's move further. So next we are going to start with your reflection of light. Okay. So what is reflection of light? So you can say a highly polished surface. A highly polished surface means like your mirror, which you see in your daily life. So they reflect most of the light. Whatever the light goes on that mirror, that will be reflected, falling on it. Correct? So and hope you guys in the previous classes you are already familiar with the laws of reflection. So what are the laws of reflection? So laws of reflection says that the angle of incidence is equal to angle of reflection, and the incident ray, normal and the mirror at the point of incidence and the reflected ray all lie in the same plane. Okay, not able to understand, don't worry, I will explain this, guys. Okay, this is very important, so I will explain with the diagram. Okay, what is your angle of incidence, what is your angle of reflection? So see, so I'm going to draw a mirror over here. So this is not a mirror, just assume it like it's the plane surface of a mirror. Okay, and suppose there is one point, suppose I'm assuming this point where the light will strike. Okay, so at this point what I will have to do, I will have to draw a perpendicular line on the mirror. I will have to draw a perpendicular, perpendicular is 90 degree on the mirror. So this is that line. So this line is called normal. This line is called normal. Normal means perpendicular to the surface of the mirror. This is called normal. Remember this, guys. A perpendicular line on the surface of the mirror is called normal. Okay, so it should be on the surface of the mirror. Now what, so suppose now light is coming and striking at this point. Okay, so I will just change the color. Okay, so suppose light is coming by this way and it is striking it over here. So of course after striking, okay, so it's coming like this. So what will happen? After striking it will go somewhere here, correct? So this will go like this. This will go like this. So what you are seeing over here, beta? So in this case, this light, the light which is coming and striking the mirror, this light is called incident ray. This light is called incident ray. Hope you guys understand this. And this light, the light after striking the surface, the light which is getting reflected, this is called your reflected ray. This is called your beta reflected ray. Okay, and again, so of course these rays are going to make some angle with normal. Okay, so the incident ray making the angle with normal is called your angle of incidence, denoted with small I, and this is called your angle of reflection, denoted with small r. Okay, so this is your plane mirror and this is your reflection. So now your laws of reflections are saying, your laws of reflection is saying, laws of reflection. So what the laws of reflection is saying? That your angle of incidence should be equal to your angle of reflection. So first law is that angle of incidence should be equal to angle of reflection. This is your first law. That's what the second law. Second law is saying that the incident ray, the reflected ray and the normal, they all lie in a same plane. Okay, so most of the students, they get confused. What do you mean by they all lie in a same plane? See, but from the same plane they mean, so like see, this particular surface, this particular whiteboard is a plane, correct? So these, all these three should be in the plane. It's not like that light is coming over here in this plane and from here it's not going on this plane, but it's going in some other direction. Like suppose it's going inside the plane or it's going outside the plane. Because see, in if you are, because this light in our daily life, we observe this light phenomena in the 3D world, okay, not in the plane. We observe this in the 3D world. So even in the 3D world, if a light ray coming like this, so it should always be follow the principle of plane. Means the plane in which that light is going coming after reflection, it should go in the same plane. It's not like going inside the plane or going outside the plane. Okay, so these are the two laws of reflection. You can check it over here. Okay, so the angle of incidence, which is your angle I, is equal to your angle of reflection, which is your angle, or this is your first law of reflection. Second, they are saying that the incident ray, normal and the reflected ray, they all lie in same plane. So these are the two laws of reflection. Guys, please make sure to memorize these two laws, because you are going to get questions on this in the exam. Okay, fine. So now after looking into this, okay, the laws of reflection is fine. So there is one thing, now we are going to start with the image formation. So before going on, I think, yeah, okay, before going on image formation, first we will discuss few things about plane mirror. So you guys know plane mirror, correct? So that's your next topic, which is very important, plane mirror, because most of the trickier questions you will receive in the exam from plane mirror only. Okay, mainly 1 mark question. Okay, so plane mirror is the mirror which you always see in your daily life, correct? So have you ever noticed, like every one of you see mirror every day, correct? So have you ever noticed down any observations on any property of the image which is formed in the mirror? Okay, so if not, I'm going to mention few properties of the image in case of plane mirror, few properties, okay, of images formed in plane mirror. What are those properties? So first property I'm going to tell you, they are of equal size of object, equal size of object, correct? And suppose your height is of 5 feet 10 inch, okay, so if you look yourself in the mirror, the your image will also have the same height, 5 feet 10 inch. It's not like your height is 5 feet 10 inch and in the mirror you are saying it's of 10 feet or it's of 2 feet. Okay, so every object, not only you, even though if you are seeing any water bottle in the mirror, so the height of the object will remain the same, like the way you are seeing that particular water bottle in with your naked eye instead of looking into the mirror. So the images of equal size of object. So this is your first property, please remember it. Second is that they are virtual image. So there are two types of image, beta. There are two types of image. One is real image and another one is your virtual image. Means real image which actually form on the screen, but the virtual image means which you can just feel, you can see, but actually that's not actual formation of the image on any screen. So the images which you see in the plane mirror, they are the virtual images, they are not real image. Okay, next property is that the images are erect. Images are erect means the way object is like suppose if you are standing and your face is up, so in the mirror also you will see that your face is up. It's not like your face is up over here and in the mirror you are seeing that your face is down. It's not possible. Okay, so that's we call erect image. Okay, so these are the few properties which you will have to remember in case of, in an exam, if you are going to ask someone is going to ask the question, what are the properties of images formed in a plane mirror. So simply write those images are equal size, okay, virtual image, erect image, and there is one more, guys, that the image formed as far behind the mirror as the object it is from it, means the distance. Suppose this is the mirror, okay, suppose this is your mirror and you are standing somewhere here, which is, I will say, suppose 2 meters. So your image will also fall 2 meter from it. So this also will be 2 meter. Getting me? It's not like you are standing in 2 meter and the image will form somewhere, no. So the distance of image from the mirror will also be the same as the distance of the object from the mirror. Okay, so I will say same distance. I will say same distance as of object. Clear, guys? Same distance as of object. 1 second. Same distance as of object. So these are the 4 properties of images formed in the plane mirror. Got it, guys? Okay. So now after this plane mirror, there is another type of mirror which are called spherical mirrors. They are called beta spherical mirrors. So now question come here, what are spherical mirrors? Okay. So I will go to those kind of mirrors. What are spherical mirrors? So now see beta, you have observed over here कि in the plane mirror, in case of plane mirror, what will happen like if the light is coming and striking on the plane mirror? So you will see some simple basic laws of reflection. Okay, so this is your plane mirror. Even though these laws of reflection will be applicable in the spherical mirrors, but what will happen if the shining surface of the object, because this one is the shining surface of the object, correct? So if the shining surface of the object is curved, what will happen if the shining surface of the object is curved? So simply you can say that mirror whose reflecting surface or the shining surface, you can say, so mirror whose reflecting surface are curved or spherical, so they are called spherical mirrors. I will explain you guys, don't worry. Okay, so come here, 1 second. So I am going to draw, so let me draw it, the smaller one. Okay, so assume this is a sphere, not a circle, assume this is a sphere. Okay, so you do one thing, cut this sphere like this. Okay, so after cutting this sphere, take out this smaller part out. Take out this smaller part out, and so this will be something like this. Correct? So this is a sphere. So what will happen? This will become a small ball. You see a ball in which you will eat. Okay, so this will become a small ball like this. This will be visible something like this. Okay, correct? Because this one is a sphere. This one is a sphere, not a circle. So this is like this. Okay. Now this, draw a line in the sphere. Draw a line in such a way that that line will pass. 1 second. Draw a line in such a way that that line will pass via the diameter of the circle, means diameter of the sphere, where the center will be somewhere here. Okay, so just draw the same line on this, the separated part of the sphere. So if I am going to draw the same line over here, so this line will be something like this, correct? So this one is this line, this one is this line. Okay, so this line is, so see this, I will explain. So this one is your spherical mirror, the separated part from a sphere, the separated part from the sphere is called your spherical mirror. Okay, and a line passing, like in that sphere, if a line passing through the diameter, or you can say the center of the sphere, okay, is called principal axis. This line is called beta principal axis, Principal, principal axis. Okay, this line is called principal axis. Remember this. The point at which it's intersecting, this point is called pole of the mirror. This point is called beta pole of the mirror. Okay, and of course this particular mirror has been separated from this sphere. So this sphere will have some center. So, and this line, this principal axis will pass through the center of the sphere. So, the center of that sphere is called center of curvature. What we call, beta, call it center of curvature. Just remember these words, these are very important words, okay? Center of curvature. So, this is denoted by letter C, this one is denoted by letter P. Pole is denoted by letter P, okay? So the midpoint between C and P, the midpoint between C and P is called F, which is called your focus. This is called your focus. Focus, focus, or it's also called focal point. This is also called beta focal point. Guys, these are very important things which I am telling. So it's very important, you will have to remember this. Ki what is principal axis? So principal axis is the line passing through the center of the sphere from which this spherical mirror has been taken. Okay. P is the pole point at which your principal axis is intersecting the spherical mirror. C is the center of curvature of the sphere from which this spherical mirror has been separated. Okay. F is the mid value, F is the midpoint between your center of curvature, F is the midpoint between your center of curvature and pole. Okay. So now distance from, remember this, the distance, your distance from C to P means CP, is called radius of curvature, is called radius of curvature. Remember this. Okay, means see, of course, but from center to this point, this is what? This is the radius, na? This is radius of the sphere, correct? So in this case, this is called, means from C to P, this is called radius of curvature. Now the distance from F to P, the distance from F to P is called focal length. What we call it, beta? Focal length, correct? And always remember that your radius of curvature, so focal length, they are also denoted with small f, okay, and radius of curvature is denoted with the letter R. Okay, so we can say that the radius of curvature is equal to twice of focal length, correct? We can say this na, that the radius of curvature is equal to twice of your focal length. Remember these words, okay, they are very important words. Okay, so apart from this, apart from your principal axis, so hope you guys understand what is principal axis, what is your pole, what is your focus, what is your focal point, what is your center of curvature, what is your radius of curvature, what is your focal length, and what is the relationship between the radius of curvature and the focal length. Okay, now I am going to tell you this. Now this spherical mirror is further divided into two types of mirror, which is called, one is called your concave, one mirror is called concave and another one is called convex. Okay, so what is the difference between concave and convex? It's very simple, beta. So if the, so this is the mirror, correct? This is the mirror. So this mirror can have shining surface either inside or outside, correct? So if any mirror whose shining surface, or you can say reflecting surface, any mirror, any spherical mirror whose reflecting surface is inside, they are called concave mirrors. They are called concave mirrors. Okay, and any spherical mirror whose reflecting surface is outside, they are called convex mirror. Remember these two terms, concave and convex. If the reflecting surface is inside, like see how to remember cave. What is cave? Okay, so cave means something where I will have to go inside, correct? Cave is something where I will have to go inside. So if inside surface is reflecting surface, so that mirror is called concave mirror, where means I will have to go inside. And opposite is convex, means outside surface is a reflecting surface, that is your convex mirror. Okay, so this is the basic concept behind your spherical mirrors. Hope you guys understand this. If not, please ask your doubts in the comment section, guys. Definitely I will get back to you. Okay, so in the spherical mirrors are of two types, convex mirror and concave mirror and convex mirror. And these are the things which I have just told you. What is principal axis, pole, focus, center of curvature, focal point, relationship between the radius of curvature and the focal length. These are the very important topics, guys. Okay, so don't miss it and just memorize it. Okay. Okay, so now what we'll have to study, we will have to study the image formation. Okay, so your next topic in your book is your image formation. Okay, so instead of going on this image formation, so image formation by these spherical mirrors, means concave mirror and concave mirror and convex mirrors. Okay, so before going on that image formation, we should know, before going on the image formation, we should know the few phenomena of ray of light. Okay, because without knowing the phenomena of ray of light, you will not be able to draw any image, or you will not be able to form any image. So it's very important to understand the phenomena of ray of light. Okay, so there are four phenomena which you will have to remember. Four phenomena. What are those phenomena? Come here. Okay, so this is your first phenomena. Okay, guys, it's very, but these four phenomena are very important. If you will not be able to understand, trust me guys, you are never going to understand this optics chapter of physics. So it's very important. So listen and see here very carefully. And okay, so see here guys, so what's the first one? So in this you can see that the reflecting surface is inside. So what kind of mirror is this? This one is your concave mirror. Okay, this one is your beta concave mirror, and this one is your reflecting surface is outside, means this one is your convex mirror. Okay, so what I have told you, this I have already told you, what is C, what is F, what is P. So in this case, since this the reflecting surface is outside, of course, always see, remember this F and C will always be the part inside only, because in this way we create the sphere, no? So they will always be inside. So let's talk about the first case of concave mirror. So they are saying the first phenomena is saying that if a ray of light, is coming, so see what will happen if a ray of light will come and strike the reflecting surface of a mirror, it will reflect, correct? So first case is that when that ray of light is parallel to your principal axis, see, so this is your ray of light which is parallel to your principal axis. So what will happen in this case? So in this case, this will come parallel to the principal axis, this will strike to the mirror and it will get reflected. So after reflection, it will always pass from your focal point, means always pass from your focus. So this is first thing, remember that if a ray of light is parallel to principal axis, so after reflection it will pass from the focus of the mirror, it will pass from the focus of the mirror. So this is the first phenomena of ray of light which you will have to remember. In case of convex, it, of course, it cannot pass like this, because it cannot cross the cross and it will go inside the mirror, it's not possible. So they get reflected like this, but the reflected ray, if you are going to extend the reflected ray, the extension of that reflected ray will pass by a focus. So this is also true in this case. Okay, so means in case of both concave and convex, in case of concave, the light will actually reflect by a focus. In case of convex mirror, the light will be reflecting, so light will the light, also the virtual, or it seems to be reflected from the focus point. Okay, and just remember beta, if you are going to, what will be the normal in this case? So normal on any of these points, the normal will always be pass via your center of curvature. So this line, the dotted line which you are seeing, that's the normal, and here also this will subtract the this will fulfill the laws of reflection, which where angle I is equal to angle R. Here also you can see, so this dotted line is your normal. You can see if you are extending, it will go to your center of curvature. Okay, and here this will also satisfy your angle I is equal to angle R. So this is your first phenomena. I will repeat again. If the light ray goes parallel, so after reflection it will pass via focus point. In case of convex mirror, if you are going to extend that reflected ray, it will pass via focus. Okay, or you can say focal point. So this is your first case. Second thing which you will have to remember, like instead of going on a parallel, if a light ray will go and pass via focal point. Like suppose this is your light ray, instead of going directly parallel and striking the surface of the mirror, it's going via the focal point of the mirror and striking the surface. It's going via the focal point of the mirror and striking the surface. So after that it will go parallel. So in this case your reflected ray will become parallel. So this is just opposite to your first point. First point, if light will go parallel, after reflection it will go via focus point. In this case, if light will go via focus point, after reflection it will go parallel. Same thing will happen in case of your convex also. See, this is the light ray which is coming. Here it's striking. Here it's striking, correct. But if you extend this, this will actually pass via focal point. And after reflection, this will go parallel to the principal axis. So this is your second point. Third one is that, guys, these are very important, okay, so you will have to memorize this. Third one is that if any light ray is passing via center of curvature and after passing via center of curvature it's going and striking on the surface of the mirror, so what will happen after reflection? It will retrace the same path. It will be reflected back to the same path. You can see this is the light ray is coming. It's coming by the center of curvature. It's coming and it's striking on the surface of the mirror. So after reflection, it's going back in the same direction, because see beta, in this case, this is the normal. Okay, suppose this is the normal. So if any light ray coming on this normal, so after reflection, it will go back, na? So the same thing will happen. I've told you that every normal will pass from the center of the curvature. So this is the normal. This is nothing but the normal of this mirror. So any light ray will go via normal, it will reflect back on the same path. Same thing will happen for the convex. And the fourth point is saying that, or if the ray of light is oblique, so instead of going, now suppose it's directly coming and striking the pole. Suppose it's directly coming and striking the pole. So of course this CP, from this CP will become your normal. This CP will become your normal. So in this case, this will simply behave like angle I is equal to angle R. In this case, it will behave nothing else. Okay. So these are the four phenomena of light which you must remember in order to start with the image formation by your spherical mirror. So we have studied here spherical mirror. What are spherical mirrors? I have told you what are convex mirror, what are concave mirror. I have already told you what are the principal, what is this, everything I have explained now. This is center of curvature, this is focus, this is principal, the relationship between the radius of the curvature and the focal point. See here, relationship between the radius of the curvature and the focal point. Okay, so in the image formation, again I have explained you, these are the four phenomena which I have explained you. Don't worry about this table. I will explain this table later when I will be explaining you the actual image formation. Then I will explain this table. Okay. So I have explained how to. So in order to make the image formation, you should know what are the phenomena of ray of light. So there's a one. This is the second. This is the third one and the fourth one. So I have explained till here. Now we'll have to start with actual image formation of concave mirror, and we will have to illustrate the same via using the ray diagram like this. Okay, so this we will study in the next video. So in this video I am wrapping up the class in this video. Till now, guys, please go watch this video again and again and try to understand what I have make you understand these things. This logic is very important to understand. If you not understand this, the four phenomena which I have told you, the ray of light which we have, and this, what is the focus, what is your center, what is your radius of curvature, what is your focal length. So this is very important to study. Okay, so go and watch this video, and please don't forget to subscribe the channel and turn on the notification, guys. Click on the bell icon and select the all notification. Why I am saying to turn on the notification? Because very soon if I am going to upload the next video, you will be notified that the next video has been uploaded and you will be able to plan your study. Okay guys, till then, bye bye, thank you.